Hello and welcome to section 9.6, which covers dilations. So dilation is making a figure bigger, which is called an enlargement, or making it smaller, which is a reduction, than the original figure while preserving the angle measurements. So the angles all still have to stay the same. You can't change the angles, otherwise you're changing the whole shape of the figure. Okay, dilation is just like camera lens or your eyeball, like how it dilates and gets bigger or smaller, lets more light in or less light in. It'd be similar to that, but with a whole shape. So center of dilation is the point about which a figure is dilated. So if they don't tell you what point it's dilated around, you have to assume it's just the origin. The scale factor that you use, that's just the ratio that it's dilated by. So if that ratio would happen to be less than 1, it would be called a reduction. And if the ratio would be greater than 1, it is an enlargement. So here is my example. So is a dilation of NO of figure JKLM, and then it dilates to the new JKLM. Is that an enlargement or a reduction? And then what is the scale factor N of the dilation? Okay, so this 0 is telling you it's rotating, or excuse me, it's dilating about the origin. So what you need to do here is you need to look at what's happening to the points. Okay, so my original J is at, it looks like 1, 3. Hang on a second, I think I plotted that J wrong. Okay, I had to fix my plotting there. I had one of my points off, and so the whole thing was off. So the original J is at 0, 2, and the new J is at 0, 1. Okay, well I have an idea just by looking at that, but you got to check all the points. And so the original M is at -2, -2, and the new M is at -1, -1. The original L is at 6, -4, and the new one is at 3, -2. I think you can see the pattern here. The original K is at 6, 0, and the new one is at 3, 0. So what happened from here to here? Looks like everything is being cut in half. So your answer would be, it's a reduction, and the scale factor is 1/2. So you're looking at the original points versus the new points and seeing what did they enlarge by or decrease by. Another example, so kind of flipping it on you. Here I give you the coordinates, or excuse me, I give you the original figure and I tell you what I want you to dilate it by, and then you have to figure out what your new coordinates are. So I have triangle PZG graphed here, the original triangle, with the original points. And this is saying dilate it by half. Okay, well that's kind of like what I just did on that other one, but backwards. So what is half of this column, basically, is what they're saying. So half of -4 is -2, half of 2 is 1, half of 4 is 2, half of -2 is -1, half of 0 is just 0, and then half of -4 is -2. So if I then need to go ahead and graph it, I guess it doesn't say to graph it, but I'm going to go ahead and do so. So -2, 1, so my new Z is right there. 2, -1 is right here. And then 0, -2 is right here. And so if I want to go ahead and draw in my new triangle, just connect those dots. And so there you can see it ends up being kind of connected to the original one. So all I did was shrink it down by 1/2. I took 1/2 of every point, and that's how it will work if you're on the X, if you're on the coordinate plane and it's telling you, if it's not saying that it's around any certain point, you have to use the origin, and then you can just cut each one in half like that. So bring that knowledge with you. We'll talk about it more the next time we see you. Have a good night.